All right, so chapter 13 is all about trigonometry, right triangles, Pythagorean theorem, that kind of thing, finding missing sides and angles in triangles. We'll also get a little bit of intro into the unit circle, which we'll use in pre-calculus. So in this section, we're specifically focusing on the Pythagorean theorem. We know the Pythagorean theorem is a squared plus b squared equals c squared. All right, this a and b value corresponds to the two short sides, which are always next to the right angle, and c is going to represent your hypotenuse. So hypotenuse is always the longest side across. Again, we call that the hypotenuse, the hypotenuse. So in your right triangles, c is always going to be the longest side, the hypotenuse, but it doesn't matter which side you label as a and b. Right? Either way would work. Both of these scenarios would be correct. It's not really going to make a difference. So to kind of explain quickly why the Pythagorean theorem is true, if we think of a right triangle here, we can see that this side has a length of 4 boxes. This side is 3 boxes long. And we know that this is actually going to be 5 boxes long if we were to kind of look at an angle. The reason we get this is because I can make a 4x4 box here. Okay, so this has an area of 16 squares altogether. I can look at this box here. This is a 3x3 box, and this is going to be a total of 9 squares. And if I look at the box that's created here, this is going to be a 5x5 box, which is 25 square units. So we know that a squared plus b squared equals c squared. Okay, so you can use kind of a little analogy with squares here and look at the area, and we know that that would be a true case. All right, there's lots of other ways to look at the comparison there. There's lots of proofs and interesting ways to show that a squared plus b squared equals c squared, but this is just kind of a common basic one that you can look at. All right, let's get some practice problems. So here we are trying to find the missing side length, and we are going to round it to the nearest hundredth. So when I'm trying these types of problems, we're going to go ahead and first identify a, b, and c. So a squared plus b squared equals c squared. All right. Actually, you know what? Instead of rounding to the nearest hundredth, I want you to actually give me the exact value. So we're going to leave a radical in this. All right. So if I'm trying to find my hypotenuse here, that means that I don't yet know the c value. So I'm going to replace the 10 and the 6 with a and b. I could do 6 squared plus 10 squared or 10 squared plus 6 squared. It doesn't matter. Okay, so I'm going to do 6 squared plus 10 squared equals c squared. We know that this is 36 plus 100 equals c squared. I'm going to add these together, so 136 equals c squared. We can try to now get c all by itself, so I'm going to take the square root of both sides. And so we get c equals, well, I can split up 136 into 4 times 34. The reason I did it like this is because I know I can take out a 4 and simplify that radical. So I should end up with c equals 2 square root of 34. All right, and that would be our answer. Okay, if there were units, obviously you'd want to include the units, but that would be an exact answer for c. All right, problem number 2. Now in this one, I know the hypotenuse is 16, and I know one of my short sides is 8. So if I'm looking for the other short side, that means I'm looking for a or b. It doesn't matter which one you're looking for, a or b, but make sure you write it like this. 8 squared plus b squared equals 16 squared. Okay, I could have written it like this, or I could have done a squared plus 8 squared equals 16 squared, okay? Either of those are correct, but the 16 has to be here because that's your hypotenuse, all right? Let's do it the first way we wrote down. All right, having trouble choosing the, sorry. All right, so if this is 64 plus b squared equals 256. I'm going to go ahead and subtract 64 on both sides. So now we've got b squared equals, let's see, 256 minus 64 is 192. 194, let's see, it looks like we can take out a 64 from that. So if I square root both sides, we get b equals the square root of 192 divided by 64 is 3. So 64 times 3. That means we get b equals 8 square root 3. All right. So trying to simplify those radicals as you go. Make sure you try to take out the largest perfect square factor. All right. Next question, is the triangle below a right triangle? So to determine if it's a right triangle, we know that a squared plus b squared has to equal c squared. All right, that has to be the case. So that means that 7 squared plus 9 squared has to equal 12 squared, because 12 is the hypotenuse, right? It's opposite the right angle. So I get 49 plus 81 equals 144. Well, 49 plus 81 is not equal to 144. That's 130. And that is not equal, so the answer here would be no. This is not a right triangle. All right, question number 4, 8, 2, and 11. Well, if I even think about a triangle like this, I know this would not even be possible to make a triangle, because if I have a side that's 11 units long, and if I have a side that's 8 units long and 2 units long, well, the 8 and the 2 is not even long enough to connect those pieces and make a triangle, okay? These two will not be long enough to connect to that third side. So I know this won't even make a triangle in general. So if it won't even make a triangle, then there's no possible way it's going to make a right triangle, okay? So again, the rule for that is that these two sides have to add up to be more than this third side, okay? If that's not the case, then you can't even make a triangle, right? Imagine making a triangle out of 2 pencils and a meter stick, right? If I have 2 pencils and a meter stick, there's no way you can connect those 3 sides to make a triangle, right? These two have to be longer when you add them together than the third side. All right, so the answer here is no. Okay, you don't even have to try a squared plus b squared equals c squared. You could, but you'd also find that it's not going to be true because, again, these two have to add up to be more than the 11. All right, some Pythagorean triples. So Pythagorean triples are whole numbers. So obviously these are all whole numbers. And these are whole numbers that work when you take a squared plus b squared equals c squared, okay? You can't just pick any 3 numbers. Like, I can't just pick, 4, 5, 6, right? This does not make a right triangle because 4 squared plus 5 squared does not equal 6 squared, right? This is 16 plus 25, this is 36, and this adds up to be 41, which we know is not equal to 36. So you can't just pick any 3 numbers and be like, oh yeah, that's a Pythagorean triple, that's gonna make a right triangle. No, there's only specific whole numbers that work out for this, okay? And that's these sets, all right? There's a lot of other sets that do work out. These are just the most common ones, okay? Now, the thing about these Pythagorean triples is that any multiples of them will also work. So 3, 4, 5 works because 3 squared plus 4 squared does equal 5 squared, right? This is 9 plus 16 equals 25, which is true. So if you take any multiple of 3, 4, 5, so if I multiply all the sides by 2, that would give me 6, 8, 10. And let's test this out. So 6 squared plus 8 squared equals 10 squared. 36 plus 64 equals 100. And that is in fact true. So it goes to show you that you can take any multiple. I could do a 6, 8, 10. I can multiply a 3, 4, 5. I can multiply everything by 5, right? That would give me 15, 20, 25. That would also work, okay? So if you take any of your Pythagorean triples here and multiply them by some number, by 2, by 3, by 4, you're going to get another one that will also work. So for example, I could take the 5, 12, 13, I could multiply everything by 3, and that means that a 15, 36, 39 triangle would in fact be a right triangle, okay? So these are called my Pythagorean triples. You'll see these a lot on the SAT or the ACT where maybe you're given 2 sides of a right triangle like 5 and 12. You could go ahead and use a Pythagorean theorem to find this missing side, but if you know your Pythagorean triples, then you know that this is going to be 13 without having to do any effort at all. So these are definitely worth memorizing, especially kind of the multiples like 6, 8, 10. All right, and that's Pythagorean theorem.